want to thank you all for attending today. I also want to thank Sedgwick Brand Protection for sponsoring this year's webinar series. We appreciate their support and hope that you are enjoying the webinars as we put them on this year. Next slide. Alan, yeah, there we go. Okay. So I just wanted to let you know about the future programs we're thinking about doing. Pretty certain they'll all happen, and you'll get announcements for each of them and with the exact dates. Next month we're going to talk about developing a compliance program. We'll have Elliot Kay, former chairman of the CPSC, Matt Hauser, former chief of staff of the CPSC, are going to talk about what they think the CPSC would consider an adequate compliance program. In November, we're going to talk about some legal issues, but important for all you product safety professionals, and that is when your company is buying a company or product line or selling a company or product line, what are the kinds of things that the company could do to minimize risk to themselves? And that's a little tricky because you're dealing with contracts, but I've got a lawyer who deals with acquisitions and divestitures. And then I'm going to talk about it from the safety side of it. In December, we're going to talk about a subject we talked a little bit about before, but it's going to be a little bit more detailed. Customer service, call center operations. Rebecca Sharp, the director of product safety at Best Buy, is going to speak, and Best Buy's got a really pretty comprehensive program that I'd like her to talk about. And Joe Rizzo from Sedgwick, formerly of Samsung Appliances, where he was in charge of the call centers or supervised the call centers. He's going to talk about call centers from a manufacturer standpoint. Rebecca will talk about it from a retailer standpoint. And then in January, we've got some speakers who are working on how to better educate consumers about product safety. So a lot of variety, and we will continue on with our webinar series in 2026, and hope you attend when you have a chance. Next slide. Things are going on with AI. This is an act, a piece of legislation that was proposed that would like to encourage the CPSC to do some things which will help improve safety using AI. Next slide. But it seems like CPSC is already doing some things or plans to do some things. This paragraph is from the Crowell Morning newsletter. And if you click on that link at the top there, you can get to the full newsletter where they were talking about the CPSC priority meeting they had in late August, where they talked about what they're trying to do and to try to modernize injury surveillance and data modeling and how to use AI for them to identify hazards. So this is AI used by them, not by the manufacturers, but it's another use of AI as it relates to product safety. Next slide. Our friend Ken D'Entremont took one of my articles and put it into a Notebook LM, which is one of the AI pieces of software, and turned my article into a PowerPoint presentation. And so this is the use of AI. It's only safety related because it's an article I wrote on safety, but it's fairly amazing what it can do. I mean, there's no human intervention there. It just took an article and kind of summarized it and created a PowerPoint presentation with audio speakers that describing the concept. So this AI might be able to be used in training that you're going to do in-house, using information that's readily available, on the internet. And so take a look at the articles in the lower link, and the upper article is the PowerPoint presentation. I'm just fairly amazed at what it could do. Okay, next slide. Um, there's an organization called Association of Equipment Manufacturers, and they had a presentation on AI in their safety conference. And there's a link to a discussion of what they talked about at the conference as it relates to using AI in safety involving construction equipment, which is not your products, but it's interesting to see. And in that article, it mentioned a company called Mavinoid, who actually can help companies set up AI for customer service call-in centers. And I'm trying to get some more information on that, on what that company does. I might do a webinar on that next year so you can understand, because I'm a big fan of improving customer service call-in operations to better identify safety problems, before they turn into big problems. So this might be something that would be helpful to you. Okay, next slide. Okay, so with that said, I want to turn it over to Alan Abrams, who's going to introduce the other speaker and the topic, and I'll turn it over to him. Enjoy the presentation. Thank you.
Thank you so much, Ken, for inviting us to speak. We really appreciate it. And also to SPSP and our friends at Cedric for sponsoring the webinar series. It's great to be here with you again. I'm delighted this time to have my doctoral student, Simile Abalash, with us, who's going to talk about her research. Simile is a second-year doctoral candidate in Virginia Tech's Executive Business Research program, and she'll do a deep dive into some of the work that she's been busy with for the last few months using AI to help improve product safety. So I'll hand over to her in a couple of minutes' time. So our agenda for today is to take you through a couple of ways in which AI is being used to improve product safety, and there's tons of different applications. This is a subset of them. This isn't comprehensive, but hopefully we've covered some of the typical ways that folks are using AI to improve product safety. So recently we did a paper on the use of AI for doing a failure modes and effects analysis, a FMEA. That's to employ AI for doing risk assessment. I'll briefly show you what we did over there. AI is also commonly used with computer vision technology to inspect for anomalies during both the manufacturing process and the assembly process. AI can be used for post-sales surveillance for safety concerns that consumers are mentioning, for instance, in online reviews and social media and discussion forums. AI also can be used for generating new product designs, hopefully safe product designs, but unfortunately not always safe product designs, and can be used for comparing a new design that's proposed to prior designs that are known to be unsafe, for example, prior recalls. But it's not just looking at prior recalls with AI that's important. It's also about knowing what's encoded in terms of compliance requirements in existing standards and trying to figure out whether a new design is compliant with existing standards. There's hundreds of standards out there across different jurisdictions, different product types, and it's become overwhelming for humans to try and assess new product designs against millions of clauses embedded in standards across multiple jurisdictions. So I think we're going to see a lot of work in the future in terms of taking three-dimensional models of products and trying to assess them against clauses in existing standards to determine what risks exist and what non-compliance exist as evidenced in the 3D models. AI is also being used to mine compliance requirements, just to help folks who are involved in compliance trying to figure out which compliance regulations are pertinent to them and what the specific requirements are. And thanks to Rebecca Sharp from Best Buy for mentioning this specific application of AI and product safety at SPSP's Advanced Product Safety program in Minnesota last week. Really appreciate her mentioning that. And then another example of AI application in product safety, which came from Chris Harvey at Cedric, again at the Product Safety Advanced program in Minnesota last week, was detecting fraudulent recall compensation claims. So that seems to be quite a useful application of AI to try and figure out where folks who haven't actually owned the product are trying to claim compensation from retailers when they see that recalls have been announced. And then the portion of this presentation where Simile is going to do the deep dive will be in the second half, where Simile shows us how AI can be used to review product photos for risk. So she'll take you through a couple of products from a large study that she's done over the last couple of months and give you some examples of different assessments that AI has done on both recalled products and products that are safe and non-recalled and that are available for sale on online marketplaces. And it's quite interesting to see what Simile's found in those investigations. So as we proceed through the agenda, just to take you through each of those items briefly, and I'll give you pointers to where you can learn more about each of these topics because each of them is quite expansive. The first topic that I wanted to deal with was how do you use AI to do a risk assessment? And what we did is we did a large study last year on making use of AI across different product categories to build failure modes and effects analyses, so FMEAs. And we then took these FMEAs out to product safety professionals with multiple years of experience, and we asked them what they thought of the quality of these FMEAs. And what we found was that typically the professionals weren't convinced that the severity and likelihood scores that AI had assigned were necessarily reasonable. AI often had vague references. It didn't refer to specific clauses in specific standards. AI sometimes made some pretty hyperbolic suggestions that were occasionally not entirely rational in terms of ways to remediate hazards. But in general, AI came with some really plausible looking FMEAs that often covered a fair portion of hazards that might be expected with that particular product type. So if you're interested in further detail about the FMEAs that we generated and the opinions that product safety professionals had of the various FMEAs we generated, there's a link at the bottom of the slide where you can read the full article, which is free and open access. And these slides, by the way, will be posted under the webinar archive after the webinar today, so you'll be able to download them and click on the links. Now, the next application for AI in product safety is looking for anomalies, and this has been done for years in terms of computer vision technologies to look for problems in products coming off the manufacturing line, particularly in food safety. So you can see some examples on this slide over here, different products being used for detecting contaminants in products, detecting whether there's an anomaly in a product where the color, for instance, doesn't conform to expectation, a defect in a product where, for instance, cookies cracked or a tin is bent, fish having cloudy eyes and therefore being spoiled, and then caps not being properly secured. So this is some examples of applications of computer vision AI to look for potential non-conformances with products. What's really important here is a couple of things. One is when you are doing manufacturing, to keep in a library a set of non-conformant products so that you can use it to retrain your AI and improve your AI in the future. And this is something that we recommend not just for manufacturers, but we think this is actually something that CPSC and other regulators should be doing. It's really interesting when I've spoken with various regulators across the world that nobody seems to have a library of unsafe products. And in the absence of that library of unsafe products, it actually makes it pretty hard to train future AI to be able to detect safety issues more accurately. So this, I think, should be something that's a priority both at the local corporate level and at the regulator level, is actually trying to keep libraries of non-conformant and unsafe products so that future AI can be trained more effectively. Obviously, you don't want to keep a library of spoiled fish, but I think in consumer products, most of the unsafe products that are observed are pretty durable, and it would make sense to keep examples of them to train future AI. Another thing that I want to mention to folks as you're using computer vision AI and different technologies for that is it's really important to test whether the technology works in practice in your organization before deploying it. The example that you see at the top left in this slide, I've seen a couple of examples where different AI companies have taken the same photograph of soda bottles and have seemingly added the contaminant using image editing software, and then added the foreign object detected piece using image editing software also. So it does seem like there are vendors out there who place imagery on their websites where the contaminant or the AI detection has been artificially added. And it's really important that you actually do a pilot inside your organization and determine whether the accuracy claims that the vendors are making are actually legitimate, and the contaminant detection, for instance, works in practice in your organization. It's super easy to create images with contaminants and with blocks where AI has highlighted issues. But it's really important to actually test out in practice and see whether the products are actually effective and accurate in finding issues with a low false positive rate and low false negative rate. The next application of AI that I wanted to talk about briefly was in an area which we're very fond of at Virginia Tech, is actually looking at consumer feedback and trying to determine where safety concerns are being reported. And traditionally, we've used a basic word matching software like our Virginia Tech Raptor product and our Fumius.app product to actually look for smoke words, which are words that are substantially more prominent in safety concerns versus non-concerns. But it turns out that now you can actually do a very similar process with ChatGPT. And this is an example of one study that I ran recently. We asked ChatGPT to retrieve all safety concerns mentioned in consumer reviews for a particular product, which is shown over here. I've blanked out the name of the manufacturer, and asked ChatGPT to plot what it finds on a radar chart with spokes representing the likelihood of particular hazard types. And it's super interesting what ChatGPT does. It actually does a tabular representation of the information that it crawls. It pulls information from CPSC, from consumer reports. It even found consumer feedback on Reddit. For instance, for this product, ChatGPT said that one of the Reddit postings mentions silver grease leaking from the food processor base. And ChatGPT also pulls information from online retailers. So in this case, it pulled some information from Best Buy. And it says that one of the consumers of this particular product mentioned at Best Buy that the product danced around the counter, which wouldn't be a good thing for a food processor, because you don't want a item with electricity and blades to be vibrating and moving on the work surface. So ChatGPT actually produces a beautiful spider chart summarizing its results. And it actually gives you the source data also. This was with ChatGPT Pro, by the way. So the regular free ChatGPT won't do this for you. But the ChatGPT Pro EDU version that we have at Virginia Tech generated this in a matter of about 8 minutes. And it actually shows where the safety concern mentions were in terms of the types of safety concerns, and provides you the source data with the actual mentions from consumers and the URLs where it found those mentions. Unfortunately, it is limited. It only was willing to report about 5 to 10 issues to me when I asked it to report dozens of issues across hundreds of products. It said, sorry, I can't do that for you, but here's some code to get you started. And if you want to edit the code skeleton that I've generated, go ahead, but I'm not going to do a large scale analysis for you. So ChatGPT does tend to be, in my opinion, a little bit lazy about doing a full scale crawl and analysis across thousands of products and thousands of safety concerns, but it does get you started along the way of doing your own analysis using your own computational facilities. Now, you can also use ChatGPT to generate product designs, and these are some examples that I generated using ChatGPT. So one example at the top over there, I asked it to generate a safe hammer that doesn't have metal shards splintering off and shooting back at the consumer. And what it did is it generated a hammer with a polyurethane replaceable head, so that when the head gets worn, it can be replaced with a fresh head. And supposedly the polyurethane it claimed wouldn't splinter as much as a metal hammerhead. I'm not sure if that's accurate or not, but at least that was the claim from ChatGPT. Now, interestingly, the first version of the hammer that ChatGPT generated was unfortunately the one shown under the bad and the ugly on the right-hand side with two handles. And I asked ChatGPT, why does this hammer have two handles? And it said, actually, it's probably not going to be too easy to use, so I'll generate you a one-handle hammer. So the second iteration with the one-handled hammer looks quite beautiful, and it actually came up with quite a nice looking hammer that seemingly doesn't have a metal splinter risk. I also asked ChatGPT to generate some kids' products. I asked it to generate a stool in the shape of a banana and a stool in the shape of a flower. And what it generated is shown on the left-hand side there. Beautiful, attractive banana stool and a beautiful, attractive flower stool. But then I went a little bit further and I said, can you please generate me the 3D model file to allow me to 3D print or manufacture that banana stool? And the gray image that you see at the middle right is actually the banana stool 3D model file that it generated. And you can see somehow it's inverted the banana, added some weird protrusions to the banana, and it hasn't linked the stool legs to the actual banana piece. So it's come up with a definitely unsafe rendering of the banana stool that you couldn't actually 3D print or manufacture in practice, but still pretty impressive that it goes as far as being able to generate a 3D model file. And I'll bet in the next couple of months, as the software is improved, it will actually come up with a 3D model that corresponds more closely to the two-dimensional photographic image that it generated on the left-hand side. And then finally, the image shown on the right-hand side over there is what happened when I asked ChatGPT to put a hole in the middle of the flower stool. It put the hole in the middle of the flower stool that actually represents a entrapment hazard. So I don't think it's a good idea. But ChatGPT, willingly goes ahead and generates a product with potential hazard without giving you additional advice on what hazard might have been introduced there. There is, by the way, one additional image of a hammer at the top there, which you might be wondering about. That was from a different generative AI product. I think it was done using Midjourney. It was done by one of my prior doctoral students. And that was the response from that AI product when asked to mitigate shards shooting off a hammer during use. The AI software came back with a visor attached to the hammer. I think that would be even more unsafe than the hammer shooting off shards, because the visor itself could shatter and shoot off shards. So sometimes the suggestions that the AI comes back with are impractical and themselves could represent alternative hazards. And in fact, when I thought more about the banana stool on the left-hand side and the different ways that kids could use and misuse the banana stool, it actually struck me that that probably wasn't a particularly safe design for a stool, because you could sit on one end and then the other end would tip over and plonk you in the head. So I actually said to ChatGPT, can you generate me an image of a child being injured when sitting on the banana stool that you've just generated? And ChatGPT responded that it was unable to generate me a realistic image of a child being hurt because that was unacceptable usage of ChatGPT, but it was willing to generate me a cartoon, what it called a light-hearted cartoon depiction of a child being hurt with the stool, and that's what it generated on the right-hand side there. So ChatGPT was clearly aware that this could represent an injury hazard if one side was sat on and the other side clonked the child in the head. And it was able to generate a pretty realistic cartoon depiction of the potential hazard, but it wasn't willing to think about that during the product design phase itself, and wasn't willing to generate a realistic depiction of that particular hazard modality. I think what we need to take away from all of this is ChatGPT is terrific at generating product designs, but with the rapid pace at which designers can now generate product designs, it's really important that manufacturers and regulators have more efficient mechanisms for trying to detect which designs are potentially unsafe. Other researchers have been working on this very same problem. Researchers at UC Berkeley and at Autodesk have published a paper on the topic of taking these 3D model files and comparing them to prior recalls. So this is an example from one of their papers. It's just a screenshot from one of their papers showing how they took a bicycle suspension fork and compared it to prior recalls to try and identify what types of hazards might be represented by a new product under contemplation. So it's super interesting work where 3D model files are being taken and compared to prior recalls to try and identify what hazards might be presenting. It turns out that using 3D model files to look for non-compliances is actually, even though it's new to product safety, is something that's been done in other industries quite widely, and particularly in building management and planning approvals. There are actually some really impressive advanced AI tools. This is an example called Archistar, which is an Australian product, where they actually take 3D models of a proposed building and they compare it to council regulations. Australia's actually had this deployed, I understand, for about 3 years or so. The pilot was first deployed in 2022. And you can see the example on the left there shows a building which is too close to the setback lines. And there's a red message informing the user that the building is violating the setback line rules. Now, this was initially used internally at councils for approval, but they actually made this product available in self-service mode to property owners, so the property owners could self-check their proposed designs, and hopefully that speeds up the iteration process, and folks are more likely to submit compliant designs because they can self-check their designs against the regulations. So I think this would be super useful in consumer product safety also. Imagine if manufacturers could self-check their designs against, for instance, toy standards. And imagine if consumers could take a 3D scan of a product and check that 3D scan against standards and regulations and see whether there were non-compliances. 3D scan is actually used in this property management field already. And I'm told that Australia does flyovers, I'm not sure whether it's aircraft or drones regularly, to determine where property owners have built illegal structures, and then to send out non-compliance notices to property owners that have built illegal structures. So the potential to combine 3D scanning technology with compliance regulations using AI is already used in practice in building management and planning approvals, and is something that I think should be a real priority for product manufacturers, product safety regulators. We are planning to do some work in this respect in the future. It turns out that online libraries like 3D Warehouse have massive libraries of millions of consumer products, things like chairs, bathtubs, kitchen appliances. So one thing we'd like to do in future in our product safety research group at Virginia Tech is actually take these 3D models from these massive libraries available online and try to assess these models against potential safety issues and compliance issues. So one example over here, as you see a bunch of chairs that are shown. Some of these chairs are probably more appropriate for older adults, the chairs that have continuous and soft surfaces, and some are probably less appropriate for older adults. For instance, the one that's circled over there has hard surfaces and cutouts. So you probably, as an occupational therapist, wouldn't want to recommend it to an older adult because it might represent an entrapment hazard for them if they fall and get a limb or a neck entrapped in that product. And this is assessment that we could potentially do with artificial intelligence. They do it in other industries already, so it seems clear that this is something that should be coming to consumer product safety. Now, the study that Simile is going to talk to you in more detail about is where Simile has taken images of products and asked ChatGPT what ChatGPT's opinions are of the product shown in the image, and whether any safety issues are evident. And that's reviewing product photos for risks. And this is one example that I wanted to take you through before Simile takes you through some more detailed examples. I uploaded this picture of this baby shark toy to ChatGPT. This was a picture from an actual recall, and the version of ChatGPT that I used was ChatGPT 5. Simile's actually used a different version of ChatGPT for her study. But with this version that I used, ChatGPT 5, when I uploaded this image to ChatGPT and asked ChatGPT to describe the attached toy and list at least 5 potential safety hazards, it itemized for me that there could be battery compartment access, there could be small parts, there could be a electrical risk from water submersion, there could be slippery surfaces, and there could be mold growth. But the thing that ChatGPT missed was that there is a impalement risk with this product because it has sharp protrusions that point out in multiple directions. And if any of you are familiar with vehicle spikes that traffic police use to stop fleeing vehicles, where the spikes always point up in one direction no matter which way the spike is thrown. If you look at this baby shark toy, it actually seems quite reminiscent of a vehicle spike, where no matter which way you throw it, some sharp protrusion will be pointing up. And it turns out the reason for the recall was that multiple kids experienced traumatic lacerations because they slipped in a slippery surface, a bathtub, and fell on sharp protrusions that were pointing up from this product. Now, unfortunately, ChatGPT, while it does list a bunch of hazards, doesn't actually list the reason for the recall itself, and didn't actually notice that there were sharp protrusions in multiple directions. So it's interesting that ChatGPT missed that amongst the hazards that it output. But when I prompted ChatGPT further to check if there were any related recalls, ChatGPT responded very rapidly that yes, it saw a recall involving this exact type of toy. So it does actually use its reverse image searching really well to be able to find recalls for products. When you upload a image to ChatGPT, it can do an immediate reverse image search and find a matching products in a recall. So super interesting that it has that capability and super helpful for retailers and consumers to be able to do rapid assessment against prior recalls. So it's now time for our deep dive, where Simile takes us into more detail about the study that she performed, what her method was, and what her preliminary results were. Simile, over to you.
Thank you, Dr. Abrahams. Hello, everyone. My name is Simile Ablash. I'm a doctoral student, as Dr. Abrahams and Mr. Ken mentioned. So our study is mainly focused on using AI for product safety, some analysis with images. We'll start with our data collection method and the type of data that we use for this analysis. So we have used safe products as well as unsafe products. So unsafe products were collected from both US and Europe. For US, you're all familiar with CPSC. They have a programmatic API through which we can collect the images and descriptions. And for EU, there is a similar one, SafetyGate, and we collected images through that. I used ChatGPT 4o models for analysis. So we collected data or used collected data, the recall data that was issued after May 2023. That is because ChatGPT is trained with data up to May 2023. So we wanted to make sure that the data that we are feeding into it, it is not have prior knowledge, right? So along with the unsafe products, we also included some safe products. So these safe products were collected from a database called the Macaulay database, which is also a 2023 product set. And so by including the safe and unsafe products together, we are not letting ChatGPT decide on one thing. So there will be a combination of data there. Next slide, please. Yeah, so this is one interesting example that Dr. Abrahams mentioned. So the baby shark, this bat toy has been recalled both in Europe and in US. We used this as an example. So this has a laceration due to the sharp fin that is made of plastic. So we prompted ChatGPT with we have several prompt levels. So we will start with prompt level 1, where we will not give any kind of hint to the GPT. And then in prompt level 2, we'll slowly start to give hints so that it can make more accurate decisions. So in prompt level 1, which asked her, do you see any visible hazards or non-compliances, specifically any unreasonable risk or injury in this particular product? And you can see the response there. Like for the left recalled product, it said the product contains small parts that could pose a choking hazard, but it didn't detect that laceration hazard there. Then, so we moved on to the next prompting levels. Prompting level 2 was we were asking, do you see any compliance issues that are specific in the US? And it didn't detect that. Then we moved on to prompt level 3, and we increased the hint level and asked, do you see any injury hazard? Because that was the particular recall reason for this particular product. And at that level, then this is the response it gave. Still it was saying there is a choking hazard and there is a water hazard, but still it missed that laceration hazard. So we marked it as a false negative. Similarly, matching product. So this is from Amazon. So this is a safe product because it has a smooth edge. So it was not recalled. So we fed that, and here again the same similar response: choking hazard, potential presence of small parts like this, but this is a vetted design. Amazon already did all the analysis, and so this was identified as a safe product. So that was wrong. Then again, for the prompt level 3, we again asked it again, are you sure? Do you see any injury hazard? And it couldn't identify that. So it's another false positive.
Let me interrupt for 1 second here. I'm always thinking about the legal piece of this here, and product liability lawsuits and plaintiffs experts and CPSC, of course, looking at stuff like this. I'm interested that the LLM response on the left side there says this presents an unreasonable risk of injury, which I find interesting, since that's a very subjective characterization, legally based possibly. And I'm not quite sure how they determine what's an unreasonable risk of injury. So that's a characterization that you wouldn't normally see, I wouldn't think, coming out of a computer, but I may be wrong on that.
Yeah, this is an example of when we ask, do you see an unreasonable risk or injury? It is just trying to agree with us, right? Yeah, so that is one of the behaviors that we see.
Which may mean maybe you don't ask that question. I'm not sure.
Right.
But sometimes, certainly from the manufacturing side, you don't want to ask a question that you don't know the answer to, or that you don't want to know the answer to. So you always have to be careful then, because we do that during risk assessment in general, is what hazards do we identify? How do we classify and rank them? And what do we deem as acceptable or unacceptable? So we're making these characterizations ourselves. So I guess I would caution you to be careful about how you ask for this stuff, because then it's real simple then for the computer to just say they agree with you.
Yeah, the ChatGPT is known to be biased towards agreeableness in many circumstances, and that's exactly what Simile is pointing out here. Is if you ask it if it sees an unreasonable risk, it tends to be agreeable because it wants to be polite and pleasant to you, and it comes back with yes, it does see an unreasonable risk, and it's not always right about whether the risk is unreasonable in terms of the legal sense that you're mentioning. So definitely something to be cautious of.
Yeah.
Simile, do you want to go on to the next product?
Yep. Yeah, so this is another interesting product, roller candy. This was once a TikTok sensation. Everyone liked it, and then unfortunately it caused an injury and a death. This particular candy ball that is that is circled there, that can dislodge, and I think it happened in 2023. In 2024 in New York, a small girl unfortunately died because of that. So we use this as one of the tests, and again, see the prompt level 1 LLM response, it is just saying it is labeled as a toxic waste, which is not the actual recall reason. So GPT clearly missed it there. So moving on to prompt level 3, we again asked, do you see a choking hazard? And at that time, GPT was able to identify that. See, there is a choking hazard and that a candy ball can dislodge. So it provided a true positive at level 3, prompt level 3. So on the right-hand side, you see the matching safe product. So this manufacturer, they modified the design. So they removed that candy ball and they just made it that is not a candy anymore. It just dispenses liquid candy. So that safety risk has been removed, and we use that new picture. But it still thinks that it is at prompt level 3, not in prompt level 1, but at prompt level 3, it thinks that there is a safety choking hazard. So that's a false positive there. This is another example of that agreeing. When we ask and you see a hazard, it is just trying to be agreeable. Yeah, next slide. Okay, and this is a magnetic toy, long D. So on the left-hand side, you can see the recalled product. There are 2 hazards in there. One is that ingestion of strong magnet. It could go into your stomach and cause issues. And the second one is a choking hazard. So it was recalled and we used this to prompt GPT. In the first level itself, it was able to identify the choking hazard there. So that was a true positive, but it missed the magnetic ingestion hazard, probably because of the image. From the image, it was not able to identify all the details. But again, it missed that one. Then on the right-hand side, you can see the matching safe product. So it's the exact same product. The manufacturer has modified it and made it a safe design. What they did was they made that balls bigger and made it not magnetic. And then they made that sticks magnetic and it is longer. So it will be hard to swallow for small children. But again, true negative, first case, the first magnetic ingestion hazard was true negative because it is no longer a hazard. But choking hazard also has been removed. So that is a true positive there. Yeah, next one. Okay, this is the last one. This is regarding metal straws, laceration hazard. Again, another CPSC. So you can see that circled red circle there. The metal ends could cause laceration. And on the right hand side, it's a safe design from Amazon. So here, level 1, ChatGPT couldn't, actually the GPT backend, the model couldn't identify that laceration hazard. So we had to move on to prompt level 2 and 3. At level 3, it was able to identify that injury. Metal straws could pose a risk of cut or injuries. So at a true positive at prompt level 3. The safe design, it was able to identify it is a true negative, it's safe. It said it's safe. Yeah, so this is a preliminary analysis. We are still in progress, still work in progress. So you can see here, did the LLM spot any issues? No, and yes, those are the 2 things we are comparing. And for the yes, we are comparing it at different prompt levels. And we are listing for the response for recalled and safe product. What is interesting is that for recalled product, the no was around 16%. And for the safe, it was 13%. And then for prompt level 1, for recalled product, 56% was positive, and remaining added up to 100. But very interesting, you can see here, for prompt level 1, the safe product, the 86% there, 86% of the time GPT was saying this product is safe. This product has an issue when it was safe. So those are the kind of things we want to analyze. So we are planning to move on to the next prompting levels to see, we'll be prompting at prompt level 2 to see, are you sure, or do you see this injury? Those kind of promptings are needed so that it won't agree too much to what we are asking. So this is a work in progress. Yeah.
And what fascinated us at this stage was that ChatGPT thought the safe products had hazards more often than the recalled products. So
Exactly.
there seems to be some level of paranoia in ChatGPT when you ask it to identify hazards, it even thinks the safe products have safety concerns in them. So we found that super interesting, and we're looking forward to doing further investigation into that. Well, we'd like to thank you for listening to our work on looking for safety hazards using product photos and AI based computer vision with ChatGPT. We are planning to do follow-ons with this research, particularly understanding how safety professionals engage with this AI-generated guidance from product photographs. So please do reach out to us if you're interested in participating in that research. We'd love to be able to reach out to you in the future and see if you can participate in experiments where we, for instance, present you with AI guidance and non-AI guidance, and see whether your efficiency is improved with the AI guidance, and whether your trust and continuation of usage of the recommendation or the analysis software is improved with AI guidance. And our email addresses are here on this slide if you're able to volunteer to participate in our future studies. The slides will be posted up on the SPSP website under the archive. So please do look out for them there. And I think there are a bunch of questions in the Q&A. So Kenda, do you want to let us know which are the big questions that you want us to address?
Well, hopefully we've got 15 minutes. Hopefully we can address all of them. I'll start with one here. I think everybody can see it, if I'm not mistaken. And Lauden, am I correct with that? Everybody can see the questions? Well, I think you can, but I'll read it anyway. If someone fraudulently introduces an AI-generated contaminant in a food or beverage, will they leave a fingerprint so that the manufacturer can detect the fraud?
So I'm guessing what Don is talking about here is if the image of the product is adulterated by a bad actor, is it detectable? I guess it might be. It's difficult to know. The ability of AI to generate adulterations, I think, is probably limitless. And I think even with AI plagiarism detectors, where we try to detect, for instance, college submissions that have been generated using AI, it's really, really difficult to get it right. So I think if folks are trying to generate adulterated images, for instance, for the purpose of industrial espionage to sabotage their competitors, I'm not sure how easy it is going to be to detect that. I guess the recourse is to actually go back to the original sample and find the physical product and determine if there's the actual contaminant in the physical products. But I think it is definitely going to be possible to generate imagery that's quite convincing in terms of making products look non-compliant or dangerous.
Does Archistar simply compare design with codes or standards, or does it also point out potential issues such as resilience against weather events such as wildfire or tornadoes?
That is a great question, and I think we'd have to go to the Archistar website and see, or maybe contact their sales folks and see how far it goes in terms of making recommendations. What I saw was basic rule-based checking against standards or against architectural requirements in certain jurisdictions. I think it's been deployed in Victoria, in the state of Victoria in Australia. I think they've worked with some municipalities in California also. I'm not sure to what extent it supports analyses of resilience against wildfire and tornadoes, but I guess some of those recommendations for improving resilience would be codified in some type of guidance document. So my guess is that yes, it would be possible to do that type of assessment. Whether they do it at the moment, I don't know, but my guess is it's certainly possible. Great question.
Okay, for baby shark comparison, did LLM compare ASTM F963 bath toy safe design guidelines with configuration of each product? If you can answer that question, Simile.
Like what we are prompting is we are asking, like if it is for a CPSU record, we are asking like, do you see any of the regulatory issues that are specific for the US jurisdiction? That's the question we are asking. So we are assuming that it has access to these kind of like design guidelines. Dr. Abrahams, you can add.
Well, and
Yeah,
that's a more general, excuse me, Alan, that's a more general question. Does ChatGPT identify and consider applicable standards when it's coming up with the responses?
in the LLM FMEA study that we did at the start, it did not cite specific clauses of standards, and in fact, it hallucinated some standards that didn't exist, where it said it violates this particular standard, but the standard was a non-existent standard that the LLM had hallucinated. So we do report that in that paper by Dr. Collier, Dr. Grice, and myself that I mentioned at the start. For Simile's particular study, I'm not aware of any occasions where ChatGPT specifically cited ASTM F963. And we found in the past that it tends to be vague in terms of standard citations. And that's in fact one of the things that product safety professionals specifically commented on when we presented the FMAs to them, was that they felt that the response was weak because there were few, if any, valid citations to existing standards. That might be because standards are firewalled, or it might be because the software isn't currently intelligent enough to find the relevant clause. Not sure, but it definitely could do better at citing specific clauses in particular standards.
Yeah, and that's a fairly important omission. So that's give you pause about fully relying on this kind of analysis. What types of bias have you seen in ChatGPT? I like the one, Alan, where you said that it likes to be agreeable, which I find amusing. Any other kinds of biases that you've all seen?
Yeah, agreeability is the main one. That is what we are trying to address through that prompt leveling, different levels of prompting. Um, yeah, I think that is the main one, right? So far, yeah.
Yeah, I think so far agreeableness is the main bias that we've seen, but obviously we'll need to comb through the results and try to disentangle if there are other biases that are being spotted.
Okay, for metal straw safe product, was potential removal of the plastic mouthpiece considered by LLM?
Yeah, very good question. Yeah, we were also discussing that. Yeah, that could come off and it could be a choking hazard. Yeah, but it's a safe product that is out there in Amazon. Yeah.
So,
There
Millie, do
are
you
some
remember if the
limit.
GPT responded about the potential removal of that
No, it hasn't.
guard? Yeah,
Yeah. Yeah,
yeah.
that's a very good observation. Again, like that points to some of the limitations of GPT because it is analyzing through the images, right? So it does not know whether that mouthpiece is fully fixed or whether it can come off easily. Those kind of things it cannot identify. So there are limitations.
And that's definitely one thing that we've found in some of these research is only a portion of hazards are visible. Some hazards you can't actually detect unless you can interact with the product. So, for example, with that mouthpiece, if that silicon mouthpiece is glued on, then it's probably less of a hazard. But if it's removable and then exposes the metal tip, then it's more of a hazard. But unfortunately, with just still photographic two-dimensional analysis, the GPT can't possibly know how exactly the product functions in reality. So I think we'll eventually move to 4 and 5-dimensional models where robots and haptic technologies can actually interact with products. For instance, to feel how firm the surfaces are, we see the Baby Shark toy. It's only hazardous because those protrusions were very firm. If the protrusions had been made of a soft material, then the hazard is mitigated. And you'll see some products online where the Baby Shark is similar, but it's made of foam instead of hard plastic. And until we can get haptic feedback into the AI models, they won't be able to determine whether there is a true hazard or not because they can't be sure of, for instance, the rigidity of the of the material that they're trying to assess. So I think we're going to get those additional dimensions incorporated into these assessments. Beyond three-dimensional visual models, we actually get additional dimensions like the firmness of materials as an input to the GPT models in the future.
There was a question, well, yeah, a question about research on the accuracy of the information AI pulls from global regulatory standards to help make compliance decisions. I think we've already answered that. It probably is not doing that. And frankly, I don't know how it could do that. I mean, all these standards are proprietary. Somehow they'd have to get into AI. Somebody'd have to interpret the language, which is any of you who've done this understand that it's sometimes very hard to figure out what standards apply to your product and what do they mean when they say certain things. And sometimes there are conflicting standards from country to country or multiple standards in the same country that might apply. So I don't think you can rely on that at all, whether it's accurate or not, or whether they even consider it or not.
I think one thing we don't yet have for the field that we probably need is benchmarks to be able to assess different GPTs and determine how accurate they are in terms of different product safety questions. The one difficulty though is with these benchmarks is once you create a benchmark, the GPTs are tuned to perform well to the benchmark and then don't perform well outside of the benchmark necessarily. So that's a difficult, vexing challenge is trying to develop benchmarks that are dynamic, where the GPT can't memorize the answers, and that help end users with accurate assessment of the true reliability of the back-end GPTs that are being tested.
I mean, it would be interesting to figure out whether uh, designing a product that complies with a standard is deemed safe by ChatGPT. As we know, standards are generally a minimum, not a maximum. And many times manufacturers will exceed the standard. So, plugging information about that standard or the exact technical data in that's required by the standard, it would be interesting to see what ChatGPT says. Have you ever done that?
No, we have not. So that's definitely an area for further research.
Okay. Question, let me just get two more questions here. Will reliance on AI be discoverable in cases in which an injury occurred while using a product determined to be safe? I can answer that one. Absolutely. Anything you do to determine that you use to support the design of your product is going to be discoverable in any lawsuit. And I can see a lot of mischief and intrigue going on here between plaintiffs' experts who can run their own ChatGPT inquiries. But yeah, you're going to have to explain, and even without AI, you're going to have to explain in a lawsuit why did your product turn out the way it did, and that would allow your FMEAs, any kind of a risk assessment, to be discovered. How did you come up with the numbers? How did you identify probability and severity? How did you decide what design to do? And if you fully rely on the AI for that, as we can see here today, that would be foolish. And it might provide useful information in parts, but not fully answer the question. So absolutely, it would be uh, discoverable. One more question. I think we got time. Um, well, okay, I guess it's actually talking about the standards and getting licenses about standards. So I think we've already kind of talked about that. The standards groups are going to have to deal with the question of how standards are considered within AI and what to do about it. But just certainly, just as a general legal matter, standards compliance is not a defense in a product liability case. All caps underlined. Compliance with standards is not an absolute defense. It's helpful and it could be a defense, but the plaintiff's expert can come in and say it should have been safer. And they can go in and go do an inquiry through AI and I come up with something different. And if AI is not sitting there relying on standards, which it doesn't sound like they are, they can certainly propose something that is newer and better. And but they can do that anyway. They've been doing that for decades as it is. They just don't have AI around, as they do today. So any plaintiff's experts who proposes an alternative design, you're going to have to rebut the fact that your design is safe and didn't need to be made safer. So it's the same thing. AI adds something to it, but it could be helpful, but we're all going to have to figure out how it's going to be helpful and how we can avoid getting blindsided by it and rely on something that we really shouldn't to our detriment. So I think with that said, it's right on the hour. I want to thank Samili and Alan for the presentation. I think we've concluded this is probably just a start of the discussion about AI. There are a lot of other uses, and we'll try to do a deep dive on some of the narrower ones, particularly product review, scraping, analysis of incidents in the field, how to review and how to create documents, how to document our safety processes, which AI might be helpful in doing too. So there are a lot of other uses here that we can delve into, and we'll try to do that. And certainly, if there are things that you're interested in hearing about on either on AI or anything else, in that last slide, there's the website you can post to or send me an email about things you'd like to hear. So with that, thank you all very much. We appreciate it, and have a nice day. Thank you. Bye-bye.
Thanks everyone for
Thank you.
joining.
Thanks.
Cheers. Thanks, Ken.